how calculators find them actually. And I'm still a bit confused as to why I made this, but this is a calculator, and you use this one in elementary and in middle school. It's just a normal Texas Instruments one. This is a graphing calculator most of you have in your bags. But some of you might also have this one, which is the rich kid calculator. Also, if you have this one, I'm disappointed in you, because that's just why you have this. Like, it's not accepted in like most standardized tests. Like, it has a query. It's like it has the output somewhere. Like, if you have this calculator, you are a bit odd. You are an odd fellow. Okay, but how do these mini computers calculate queries? And I'm calling them mini computers because calculators are actually, the ones that we have, are more powerful than what is used to send the rockets to the moon. So these are actually pretty powerful. And I found the answer from some random guy on Quora. And this guy's name, his name is Andrew Burman. And he's a research engineer at a pseudo polymath. And he had a very good answer, actually. Like, I'm kind of making a joke about it, but he actually is really smart. And he had a really good answer. And it's a bit cut off, so let me just read it from my iPad. So what he said is, so now that we've gone this far, you might think, if you look at the other answers, that the solution is to use a method like Newton-Raphson iteration to calculate the square root. And basically, to do the Newton-Raphson, you do x initial, that's x initial, plus 1, which is equal to 1/2 x initial, 1/2 times x initial plus n over x initial. That's a lot of x initial, but there's a reason that you don't use this one, and you use what? You don't use it because when you do, can you go back up actually? Because I want to show them the formula again. Because when you divide, you do n divided by x initial, that actually is very inefficient. So doing 1 divided by 2 is fine because everyone knows that's 0.5 and that's easy for a calculator to do. But this is a variable, and when calculators divide their variables, it's just not great. It's not efficient. So let's go to the next one. This is the second one, and this is actually a much better formula. It also is Newton-Raphson, but it's written a little differently. And here, there is no dividing by x initial. And this one is actually pretty good. But there's actually even a better way to do this. And this is it. It's called Goldschmidt's algorithm. And I would lie to you if I said I understood this. So let me just, let me see if I can summarize what this says though. Basically, you use a lot of B initial and you use a lot of like B whatever's, and you use that to, you find Bn, and then you also get the square root, and then once you get those, you're able to find something which will approach the square root of B initial. So basically just going through this convoluted mess will help you find the square root of B initial, which is what you want to find. And that's the best algorithm for calculators. Thank you for watching. Let's go on a little more. Sorry. Oh, yeah, let's go on a bit more. Yeah.
Sorry.
Okay. Mr. Farris can do his lesson.